And that was Darwin's totally made-up lecture on quantum seagrass. It's just being silly. See you next week for more Dolphin comedy.
Just kidding.
Ya ora na, beautiful ocean souls. I'm Moana, and this is Darwin, and you've just dropped into our world where science meets the sacred rhythm of the waves. Today we are diving into two incredible stories that will change how you see our ocean forever. We'll slip into the red-lit world of midnight research boats, where scientists chase glowing mysteries, and then visit a tiny German island where the world's longest ocean diary is revealing climate secrets. In the next 20 minutes, we'll explore 3 chapters. First, the epic 62-year data collection from Helgoland Roads. Think of it as the ocean's longest Instagram story, but with scientific precision. Then we'll join night shift marine biologists, discovering creatures that light up like underwater Christmas trees. And finally, connect these dots to understand why it matters. The ocean holds 99% of our planet's livable volume, almost all the space where life can exist. Yet we've explored less than 5% of it. Tonight, we're changing that ratio. Chapter 1. Helgoland Roads. Picture this. It's 1962. The Beatles are about to release Love Me Do.
Love, love me do.
And on a small rocky island in the North Sea, German scientists begin what will become the ocean's most important diary, Respectful. Every single workday for the past 62 years, someone has walked to the same spot, dropped a bucket into the water, and recorded what they found. Helgoland Roads sits at coordinates that might sound boring, but they're as precious as any treasure map. This is the longest non-stop coastal data collection in ocean history, and it's revealing something mind-blowing. The water has warmed by 1.13 degrees Celsius from 1962 to 2023, a seemingly tiny shift with enormous consequences. That might not sound like much, barely noticeable in your morning coffee. But in ocean terms, it's like cranking up the planetary thermostat. The warming rate is 0.0282 degrees Celsius per year, which means we're watching climate change happen in real time. But here's where it gets interesting, and this is where the ocean starts whispering its secrets. You think warmer water would make the spring tiny plant bloom happen earlier, right? Like flowers blooming sooner in a warm spring? Wrong. The opposite is happening. The spring bloom of diatoms, tiny plant powerhouses that fuel our entire marine food web, is actually shifting later in the year, toward the end of March. The ocean is hitting the snooze button on spring, and scientists think they know why. Darwin's doing his chart-rising impression is pointing out that when autumn temperatures get warmer, it confuses a tiny algae's internal clock.
What?
It's like when you have a really warm December and your plants don't know whether to go dormant or keep growing. The ocean remembers. These tiny diatoms respond to temperature signals from months before, creating a domino effect that ripples through the entire North Sea ecosystem. When the base of the food chain shifts its timing, everything else has to adapt or struggle. The researchers found that the bloom shape itself is changing. Instead of a gentle rise in early spring, it's no more like a steep cliff at the end of March. Picture switching from a gradual sunrise to suddenly flipping on stadium lights. That's what's happening to marine life in the North Sea. Chapitre 2. Night Shift Biology. These aren't just isolated discoveries, they're part of a bigger pattern scientists are uncovering around the world. Let's teleport to the deck of a research vessel in the midnight Pacific, where it's 2 a.m., the deck lights glow red to preserve everyone's night vision, and scientists are about to witness one of nature's most incredible light shows. A marine biologist from recent expeditions recently told us, first time you see creatures making their own light through the underwater robot cameras. It's like discovering an alien world in your own backyard. We're talking about animals that glow, 3,000 meters down where the sun has never touched. This is the world of nighttime ocean exploration. Robot submarines diving into the deep while we sleep, capturing footage of life forms that seem almost magical. Recent research shows that making your own light is far more common than we thought in the deep ocean. Here's what really blew my mind. Some of these creatures vomit light. I'm not making this up. When threatened, certain shrimp species literally throw out glowing stuff to confuse predators. It's like having a built-in emergency flare, except it's made of living chemistry. One incredible discovery came from researchers at the Monterey Bay Aquarium Research Institute. They found Bathocordes macnuti, a giant lavation that creates massive mucus houses in the deep ocean, some as big as trucks. These transparent creatures are like underwater architects, building temporary homes that filter tiny particles from the water. Darwin, sometimes you sound like the predator. Darwin's asking if tiny sea creatures get sleepy. Actually, that's not as silly as it sounds. These tiny animals have internal clocks, timekeepers that tell them when it's day or night, just like us. Research shows that even in the eternal darkness of the deep ocean, life keeps time. Here's the really cool part. When these tiny creatures, called copepods, migrate up and down through the water column, traveling up to 600 meters every single day, they're following ancient biological rhythms. It's the largest migration on Earth, and it happens every single night, invisible to us surface dwellers. The red lights on research vessels aren't just for human eyes. They are crucial for not disturbing these light-sensitive creatures. When scientists use white lights, they actually change how the animals behave. The ocean's twilight zone, that mysterious deep ocean layer between 200 and 1,000 meters, is like a giant underwater city where creatures time their movements with incredible precision. And climate change is starting to alter these ancient rhythms, just like it's changing spring blooms at Helgoland. Chapter 3. Why it all matters. So here we are, connecting the dots between a German island's 62-year weather diary and glowing creatures in the deep ocean. What's the bigger picture, you ask? The warming trends at Helgoland Roads from 1962 to 2023 aren't unique to the North Sea. They are part of a global pattern, where ocean temperatures are rising faster than at any point in recorded history. And those delayed spring blooms, they're creating ripple effects through entire food webs, throwing everything out of sync. When tiny diatoms shift their timing, it affects the tiny copepods that eat them. When copepods are out of rhythm, it affects the fish that depend on them. As fish populations struggle, the impact echoes up to seabirds, marine mammals, and fishing communities. Glowing creatures we're discovering in the deep ocean tell us a similar story. Many of these species are indicators of ocean health, like canaries in a coal mine, but with their own built-in flashlights. When their behavior changes, it's often a sign that deeper changes are happening in ocean chemistry and temperature. But here's the thing, and this is where my Polynesian ancestors would nod in recognition. The ocean is our mirror. When we learn to read its signals, we're learning to read the pulse of our planet. Ancient Polynesian navigators knew this, and they could read the ocean's moods, its rhythms, its secret messages written in wave patterns and bird flights. Darwin's reminding us that science isn't just about collecting data. It's about understanding our place in the web of life. Every temperature reading from Helgoland, every glowing flash captured by underwater robots, every tiny creature's daily migration is part of a story that connects us all. Now, you might be wondering about some common ocean myths. The ocean isn't getting more acidic because of pollution from ships. It's actually because it's absorbing excess CO2 from the atmosphere like a giant sponge, soaking up our carbon emissions. And that deep ocean we're exploring, it's not empty. It's the largest living space on Earth, home to creatures that have been perfecting the art of making light for millions of years. So what can you do with this knowledge? First, if you're inspired by coral reef research, check out coral restoration programs. Links are in the show notes. You can help restore damaged reefs for roughly the cost of a pizza night. Second, share this episode with one friend who thinks science is boring. Trust me, after hearing about shrimp that vomit light and tiny creatures with their own clocks, they never look at the ocean the same way.
Wow!
If you'd like to support our work, check out the links below for ways to dive deeper into our ocean conversations. Remember, part of our support goes directly to coral restoration projects here in Moorea, where we're actively helping heal reef systems. Your curiosity literally helps heal the ocean. Let's take a moment to connect with the ocean's rhythm. Close your eyes if you can, and breathe with me. Breathe in. Feel the vastness of the ocean. From the sunlit surface to the deep layers where creatures make their own light. Breathe out. And feel gratitude for the scientists who spend their nights collecting data that helps us understand our world. What did the waves whisper to you? The ocean is always speaking. We just need to learn how to listen. And that's a wrap on tonight's journey through... Darwin? Darwin, where'd you go? I know you were just here. Darwin? Don't tell me you've gone back to give those copperpods a lecture on proper sleep schedules.
Eee, you've splashed me again!
There he is. Should have known you'd make a dramatic exit. Classic Darwin. Stay salty, stay curious, and remember the ocean connects us all. Moruru, beautiful souls. With love and ocean vibes,